Okay. Yeah. So just to get into this, I really don't know how much of these kind of basic concepts Mohammed has covered so far in the lectures. But what we're just going to focus on here is web scraping, specifically going to an HTML website, taking data from it, and loading it into a Python system and Python environment so that you can do some sort of very basic data analysis, analytics, and some visualization model fitting at the end. So the first assignment, I believe, is just web scraping, formatting into a table, and maybe some visualization. So no model fitting just yet. That'll come in later assignments, and that'll kind of be the crux of the final project, is building at some level some sort of model that's predictive to some degree. Okay, so the data set we're going to be working with here this is a bit of an old Python notebook. I made this a couple semesters ago for the course. So the data set I'm using is just kind of this live ticker I found online of COVID cases. So obviously this doesn't pertain as directly to our daily lives anymore, but still pretty important. And I believe the information here is kept up to date, at least at a granular level of a day. So basically what this website is doing, it's a very basic HTML page just displaying this information. And it displays basically per country, or just as the world breakdown, the total number of cases for COVID-19, and what's updated frequently is the new deaths, the new people who have recovered from the disease, new diagnoses. So what we're going to do is we're going to write a very basic Python script that's going to go through. It's going to extract all this table data. It's going to remove all the noise from it. Do a little bit of handling missing data, handling kind of finicky data that will break down certain models, and doing some very basic data manipulation analysis. So yeah, this is the website. There's really nothing special here. This is a pretty up-to-date HTML page. So sometimes depends on the data source you're using or kind of where you're going to get your data. Some of these HTML pages might be considerably out of date, and it's actually easier to work with just because the HTML itself is very easy for Python to read, versus some of these newer sites that use HTML5. It can be a bit harder to parse. And we'll see some of that later on as we go through this notebook. But yeah, so when I say web scraping, I might just throw that term around. What that basically means is that you're going to a publicly available website, almost always an HTML page. These codes will work for like XML and other variants on web pages, but we're focusing on HTML. We're going to go to that website. We're going to take the data from it. It's usually displayed in a table, and we're just going to process it. So that's scraping a website for its data. Yeah. So I also do want to mention that most of the stuff is kind of assuming at least some basic knowledge of Python. If you have, this is like your first time seeing Python, then it might be a little bit overwhelming. And if so, I'd encourage you to look at some tutorials for Python online, or come to my office hours as you see fit and ask me questions. More than happy to help out. What I'm going to do here, though, is going to pretty much assume that you at least know the basics of Python. Yeah. Okay. So preliminaries. Most of what this notebook is going to be is it's going to be several cell blocks of code that should be pretty modular, that you can take and kind of directly copy over and do some slight adaptation for different purposes. Because a lot of the times, especially with plotting, these plotting scripts are pretty easy to use. It's just a matter of getting a test example to look at and kind of adapt as you see fit. So most of this code is going to be pretty useful when you do your assignments and whatnot, that you should go to it and kind of see what exactly it's doing, how it's outputting the results, and kind of adapt it to your needs. That's a lot of data science, is taking people's codes and adapting it to what you need. Yeah.
So, and if you're going to answer this later, just tell me when you get to it.
Sure.
The one that's a Python init notebook connect true. What is that?
Where
In the
is?
second block under plotting.
Oh, okay. Yeah. So this, it's not something I'm going to mention. It's just basically telling the Colab notebook to initialize all my Python environments here. And that's going to help later on. You usually don't need to use this command, but it will come up later on, where sometimes if you try and generate figures in a Python notebook, and it's not being run locally, so Colab notebooks are run in the cloud, it'll try to render the image and it'll send it somewhere, and it won't necessarily put it on your machine. So what this is going to tell it to do is that keep everything here. But yeah, so basically that's a whole long preamble to say that this preliminaries kind of cell block here is just a lot of the Python packages that you'll need for most of your data science needs. So these general ones like NumPy, Pandas, are for handling data and putting it into a data frame. Math and random will do a lot of the mathematical functions you need. All these packages here are going to be pretty much used for plotting. When we get to that section of the notebook, you'll see how exactly to use them. But these are the kind of the core ones: Plotly, Matplotlib, Seaborn. And then I have some other basic utilities here that might not come up. Well, Beautiful Soup and requests will come up. These are the two main things they're going to use to actually extract websites, but the rest of them might not come up. Warnings ignore is just my personal, I hate when Python tells me my code is not efficient. It'll warn me. I don't like it when it does me that. I know what I'm doing is inefficient. It's going to be fine. So I like to suppress those warnings. But yeah, that's basically all this cell block is telling me. So if we want to get into the actual web scraping aspects, so to get started, this cell block here is going to be the basics of using Beautiful Soup to get the raw content of an HTML page. So what I'm doing is I'm first declaring a variable that's going to store my web URL. So this is just the website that we were just looking at for this COVID-19 tracking. And all I'm going to do is I'm going to pass it as a request to the request package. I'm going to say, I'm looking at this website. The user agent is defining what kind of system I'm accessing it with. So I'm accessing it from Safari. And just all I want is you to collect that HTML page, give it to me as just a raw file. I'm going to do further analytics on top of that. So the request is just going to make a request. It's going to pull that website. At the time of me running the script, that's when the request is made. So it's going to make a static version of the website. And then I'm making a few variables here. So URL open is just saying, open that URL. I have it now loaded into a variable, and soup.web page or soup run on that web page with an HTML parser is going to say, okay, what I just told you to load in is an HTML file, parse it as such. And Python is able to do that. It's going to parse out different blocks of it because now it knows to look for HTML tags. So again, all of this is automated. You don't need to know anything about HTML to really do these kind of analytics. Okay, and then there's just some other basic variable definitions here that'll come up later. So I'm loading in what today's date is because I'm going to use that for printing purposes and to kind of modulate some of the data. And I'm declaring this parameter called true, which I don't really need to do, but we'll see it later on. Okay, so let me actually run some of these packages to make sure everything's working. So run this one to make sure all our packages are imported and make the request to get the website. And let's hope that doesn't fail. Cool. Okay, so now in this page_soup variable name is where I've requested the website. I've brought it into Python. I've decided to parse it using HTML or told it that is an HTML so we can parse it. So if I print just that variable name, what you'll see is just a whole mess of HTML script. This is not something we can work with. This is just the entire code that builds that website we were just looking at. And obviously, we're not really interested in the entire website. There's one specific block of it, that table, that we actually want to grab. So what we need to do is we need to further parse this. So at least Python knows we're working with an HTML script, so I can feed it more tags for HTML to tell it where in that file to look for the information I'm looking for. So first what I do is using that page_soup, which again is just storing this variable, I'm going to find all instances of tables. So in HTML, luckily, when they have a table, they call it table. That's a very basic tag. So I can feed that directly in. I can tell the Python script, look within that HTML file, find any table. So that should refine our search a little bit. It'll narrow down what we're looking at in this HTML page. And what you'll see here is that it's found a whole bunch of tables. So it's found table, bordered table, main tabled countries, yada, yada, yada. It's still kind of messy. I still have no idea really what I'm looking at. So what that's telling me is that, okay, it found all the tables on this website and there's more than one. So that's kind of an issue because the only one that I want is this one that I'm specifically looking at. So what you can further do is getting past all that. Let me make sure I run this. So load that in. And so now what we want to further do is we want to further refine our search. So the first time I called find all tables, I just said, give me any table. And that wasn't good enough. So now what I need to do is I need to feed in the actual name of the table I'm looking for. So the table that we're actually looking for is called main tabled countries today. That's how whoever wrote this website name their table. The way I found that was actually just by printing the names of all the tables, but an easy way of also doing this is kind of the old-fashioned way, I guess, where if you go to the website and you pull up the web inspector, so people who have never played with the web inspector, you can look directly at the HTML code and you can scroll through it to see exactly which bits of the code are displaying which aspects of the table or the website. So what I've done here is I'm just scrolling through and you'll see that it'll highlight certain regions of what I'm looking at. So specifically, I want the actual contents of the page. I'm not looking at any of the backend stuff. So when I highlight over this container, it seems to show me that all the website is contained within this aspect. So I can further refine within this, and I can look within this website for the actual contents. So it looks like the contents are in here. And I can kind of keep whittling down to look for some sort of table. Not seeing it. Oh, that's it. Table content. Cool. And if we just keep going down within this, so you'll see that we actually found exactly the table we're looking for. So that was kind of really the old way of doing it, is just looking through the HTML script and getting it to highlight the thing that I want. The easier way of, yeah, sorry.
The other way is like you literally just pick the first row, right click and inspect, and go straight to that line.
That also works. I didn't even know that. So I'm doing the old-fashioned way, but yeah, so this will take you directly to the actual name of the table. You can just kind of visually inspect and get that. Or you can use Python to automatically output all the table names, and that's another way of parsing further. For when I basically wrote this kind of stream of conscious, this notebook, so it's just the way that I was doing it, and it seemed easiest to me to pull up the actual ID. So that's what I did. I got the ID. I got the main table countries today. So I say, okay, Python, find the table, and specifically I'm looking for this one. And to further break down some of the nitty-gritties of this bit here. So this cell block is probably going to be one of the most important ones in this notebook in terms of web scraping specifically. So if you're doing a very bare bones approach where you pull out the HTML script for the table, then you need to parse through individual rows using what's given to you by HTML. You need to extract the data that you want. So what this is going to do is this first line is going to give me all the HTML pertaining specifically to the table I'm looking at. And then what this is going to do is, now that I have that table, I'm going to tell it to look at the TRs. This is an HTML flag that just stands for the row names. So I'm going to tell it to go through all the rows and give me anything that's of the style two empty quotes. And basically what that means is look for anything that's a string. Two empty quotes is telling me, well, I'm not looking for an integer, I'm looking for something else. So what this is going to do is it's going to look at the first column. So that's this table indexed at 0. It's going to go through all the rows and it's going to give me any string. So what that's doing is it's going to this table. It's saying, okay, restrict yourself to this first column, and that's countries. And I'm asking for it to give me anything that's a string, which should naturally give me the name of every country. So I called this variable containers, which is a bad name. It should be countries. That's on me, but that's all right. So we have all the country names in this variable. And now what we want to do is we want to collect all of our data into a big array. So I do initialize an empty array, call it all data. And what I'm going to do is I'm going to iterate over all the country names, which are my labels for the rows. And as I iterate, I'm going to collect the data for each country and I'm going to stack it up on my array. So basically what all data is just an empty big array. And in each instance, I'm going to get all the data from a row and I'm going to stack it into that array. And I'm going to go to the next row. I'm going to stack that one in. I'm just going to keep stacking them up. Yeah, so country data, I'm going to go into this country. I'm going to find all TD. So TR is getting me all the rows. TD will get me all the columns. So if I'm restricting to one country, give me all the column data for that country, put it in a variable. And then what this whole block is going to do is some pre-processing. But before we get into that, basically, I'm going to take the data. I'm going to put it in this country container variable. I'm going to clean it up a bit, and then I'm going to stack it into my data. So this all data I'm going to append to this country's data. So any questions on that high level procedure? This is kind of the basics of just grabbing a table from HTML. over Zoom as well. If there's any questions, let me know. Okay, cool. So to break down some of the pre-processing that I did here. So I did very basic pre-processing just to kind of what I noted in a very quick scroll through of the actual data set. So a few things are trying to find a good instance. Well, for one, there's a lot of blocks that would say NA, that's a not available number. So I need to make sure that I flag those so that I know I need to do something with the missing data. I can't interpolate using missing data. There's a lot of empty cell blocks that I need to account for. Whenever there's a plus 463, that's obviously it's denoting some sort of change. It's saying 463 more cases. But if that's in the column of new cases, then I know it has to be an increase. So I'm going to remove those plus signs. Similarly, I'm going to go through and remove any negative signs because those are clear from context that they're negative numbers. And yeah, there were some issues when I initially coded up this notebook where the China data set was reading in with special characters that were non-numeric. So I decided just to omit them from my analysis. This is very much not a political statement. This is just, I could not read this data the first time I made this notebook. So I decided to remove China's data, which is okay. And yeah, the other cleaning steps here are whenever there's a comma in a number, I decided just to remove the comma because Python's not going to read numbers with commas. Like I said, I'm removing any plus signs, I'm removing any minus signs. And so that's what this clean parameter is doing. So if I want to clean the data, this is how I would do it. I would remove plus signs, commas, negative signs, just so that everything looks like a number to me or to Python. And then to handle missing data, so if the feature that I'm looking at is not available, I'm just going to replace it by a 0. And if it's just an empty cell block, so if there's nothing in it or if there's a space, I'm going to replace it by a -1. This is just kind of to show two different ways you can maybe denote to yourself that you have missing data. -1's probably the more conventional kind of tag for a missing data cell, especially if you're working with entirely positive numbers, because if you're running your analysis and you run into a negative number, then that should basically tell you, okay, this is a piece of data that I don't have access to, so I need to handle it somehow. We're not going to deal with missing data here. It is a very important thing. Specifically, like if one of these countries, if only one of the countries out of, say, all of them, doesn't give me the new cases for the day, a way of interpreting that is that you can, or interpolating that value is to just take the average of all the other countries and plug that in there. You can usually do that without a loss in generality. There's like handling missing data is a whole open area of research and statistics. It's very much a non-trivial task. But it is good to know some best practices. A lot of the times, so I recently had an interview like for a more data sciencey job, and one of like the main aspects, a lot of times data science interviews will ask you, they'll run you through and they'll say, okay, I need to collect data from here. How do I get it? How do I pre-process it? What do I do if there's corrupted data? And so obviously some ways you can do that are to interpolate the value, or you can just say, we can throw out that data if your data set's big enough. So it's definitely something to be mindful of, and knowing what the pipeline is to get data and handle these kind of very common issues is hugely important in data science. Okay, so I went kind of quickly over a lot of Python here. Any questions on loading things into data? Okay. Okay, so what did we do here? We removed irregular characters. We replaced unavailable entries as zeros. We replaced some missing data with -1. Again, just to kind of showcase the different ways you can handle this. Just kind of flagging to yourself that you need to later revisit and replace these values. But for the most part, we have all the data from this table loaded into this variable all data. And so now what I want to do is I want to transition to using pandas, which is a huge Python package specifically for data analytics and doing statistics on big data sets. So pandas is something that will come up a lot when you apply for jobs in data science. It's something that you should be very proficient in using. So I'm going to take my array, I'm going to cast it into the pandas framework, which is a data frame. Then I'm going to denote as df. And I'm going to drop the last few columns just because they're not really relevant for the purposes of this lecture. and I'm going to print out what our data looks like. So did I run this one? No, we'll do that. Okay, so doing data frame.head is just going to give me the top of my table so I can visualize what I've done so far. So you can see that so far we have the data, we have all the columns. We lost the column names, which is an issue. If you remember on the website, all the column names are listed, which is good. We need to add that back in. But we do have each row labeled by the country. This final column is giving us the continents, and we have all our data loaded in a numeric form. So all the commas are gone. These negative ones are missing values. Obviously, there's a lot of them. And yeah, but for the most part, we have everything loaded into a data frame now. So what I did next is I added back in the column labels because I kind of accidentally removed them out. There is a more sophisticated way of loading things into a data frame so that it automatically identifies the column labels and uses them. I didn't do that here, and just because I was coding this kind of fast, but basically I just went back and I added back in the column names by hand. So I got all the column names, I just copied them over from the website, and then dataframe.columns will specify all the column names. And so loading them back in, now I have what the data should actually look like as a data frame. So it's almost identical as before. All I've done is I've relabeled the columns so I know what they are. Even though I'm never really going to call a column by its name because they're these very long names that aren't really useful. In theory, you could go back and you could rewrite all the column names and like relabel total cases as TC or something if you want to be easier to access that data specifically. Because data frames do handle if I pass it. If I called DF new cases, it would give me the whole column for new cases. So you can abbreviate those as you want if you would prefer. For the most part, I'm not going to access single columns, so I'm just going to leave it. So we can add those back in. We have that. Okay. So one other thing that I noticed when I was loading things into data, the first time I did this, was that there were a lot of countries that you would think their data should be listed here, but it wasn't coming up. So what I noticed was that a lot of this data is actually present in the HTML file, but it's under the tag of MT underscore A, which is basically saying don't display this to the public user. So for whatever reason, they decided only to display the information for a subset of the countries, not all of them. So I went through and just got the full list of countries. I iterated over them and I just printed out the name of any country that was not available in the table that I created. And you'll see here that there's actually quite a few, like the Ukraine, France, South Korea, and so on. So I'm not personally going to do anything with that. I could go back through and make the HTML script display that information to me. But this is kind of more of just a lesson in the fact that the data you have doesn't always represent everyone you're trying to represent. So you always need to, especially in interviews, need to express when you're creating models based on data and you're using them to be predictive or to classify things. One thing that interviewers are oftentimes looking for is that you emphasize the limitations of your data. So you should know that your data does not always represent everyone that you're looking at, and you need to be wary of, certain demographics or certain communities that your data does not represent. So yeah, those are some missing countries. I'm not going to add them back in here, but it's important to be mindful of that. And some final pre-processing here. So what am I doing here? Oh, so in this block, what I'm doing is I'm just iterating over the column names for any label in the list of column names. There are exactly 2 columns entries that are not going to be numbers. They're just going to be strings. So specifically the country and the continent. So for any column that's not the country or continent, I'm going to cast the variable there to a numeric. And the reason why I'm doing that is that even though right here, this looks nice, it's giving me these numbers here, giving me the total population or the total number of recovered. At the moment, Python just sees those as strings. I need to tell it that you need to convert those into integers so I can do actual analytics. So I'm going to iterate over all my numeric features, and I'm going to cast them to a numeric entry. And this should cast them to an int64, which is 64-bit memory, so it's going to be big enough to handle these numbers. What else do I do? Oh yeah. Okay. So I also add in 3 new columns just kind of to showcase how you add columns to a data frame. So I just specify the name of the column I want to add, which isn't currently there, which means Python is automatically going to add those columns in. And so I added one for the % increases in cases, deaths, and recovered, which is just calculating the division of 2 columns and then multiplying by 100. So number of new cases divided by total cases times 100 will give me my % incidence. So that's just me designing new features on top of exactly what the data has given me. This doesn't actually give me any new information. It's just kind of a different representation of the information that we already have. Yeah, okay. And then just printing out my data frame to see what everything looks like, make sure everything's fine. So if I print the data frame, you see we have all our column names. Everything should be represented as integers now. In the instances where things were decimals, the toNumeric command converted them to decimals, which is good. And we have our continent, and my 3 new columns have also been added in here. Yeah. Okay. And then just more so get some very basic information on the data that I've collected. If you do dataframe.info, it's going to list all the features that I have. So each column, it's going to give me their name. It's going to give me how many values I have for that variable, and it's going to give me the data type. So the country and the continent are being listed as objects, which are just strings. Everyone else is either an int64 or a float64. And another intentional bug that I threw in here is that you'll see my % recovered. So all these things, these 209 is telling me the number of data points that I have. So for each feature, I have 209 data points. But specifically for % recovered, % increase in the recovered, you'll see that there's 20 missing. So when you do the data.info and you look at your data frame and you see something like that, that should be a red flag, because that's a feature I added, which means something I did made it so that Python couldn't add in 20 specific values. And the reason for that, if you scroll through, so on this % recovered, you'll see I actually created a bunch of not availables. NANs within the % recovered, and NANs usually indicate that you're doing some sort of division by 0, or 0 divided by 0. Yeah.
Quick question: is there a way of formatting like the %, so it actually is like a % instead of scientific notation? Or
you can make it with the percentage at the end, or you could multiply by 100 to get that. But that would make it a string, which is going to be harder to work with.
Got it. So the moment you format it, it goes back to string.
Yeah. Yeah. Anytime you throw in a non-numeric character. Yeah. So when I did this % increase in the recovered, I divided by 0 somewhere, or I did a 0 divided by 0, something to that effect, which is not allowed in Python. So it just didn't do that operation, and it didn't add them into the data frame. So that's kind of the utility of just printing out the information on your data to make sure that you've handled any possible mistakes you've made. But going forward, we're not actually going to use that column. That's just an example to show you what could go wrong. And yeah, if you do the describe method on your data frame, it's going to give you the most basic statistics for all the variables you have. So what this does, it counts, again, the number of instances of each feature. It's going to give me the mean, standard deviation, all kind of the very basic things you might need to just do some very basic survey of your data. And that's essentially the absolute basics for web scraping specifically. So before we get into plotting and model fitting, are there any questions? For people who have started on the assignment, have you been able to do the bulk of this so far? Yeah.
So the columns here happen to be nicely sort of in their columns, but
right.
Sometimes like you'll have multiple columns in the table, but it's not a strict table, right?
Sure.
But then you have to kind of take this piece and say, well, this piece is actually one string. It's actually 4 columns.
Right.
Can you go through some of the ways to like split those apart or find tags?
Yeah. So this will come up in your first assignment, I think in the 3rd or final part. But basically, if you just read the HTML as is, it's going to stack a whole bunch of columns into one. It's going to call it one column. So what you need to do there is you need to tell HTML to further look at the specific column name and parse it by spaces. So I don't want to pull it up just yet because I'm going to kind of leave you to try and do that and kind of Google around. But there is specific ways where, yeah, you can tell it that what you've collected here, this column name, this should be split. So you can say, okay, in each row, also make sure that don't just look for columns, look for spaces between entities. And so even though it thinks everything's a string, when it finds those spaces, it's going to say, oh, I should actually separate this into multiple values. And you can do the same thing for column or commas or dashes or whatever character you might have. But yeah, good question. That will come up on the assignment. Other questions? While I run this. Okay. So now I'm just going to run through some very basic plots using Plotly and Matplotlib. These are, again, the two kind of most common things you'll see in terms of data visualization. Most people for scientific publications will use Matplot or Seaborn. I think I have some examples with Seaborn in here as well. But yeah, at least for me, I never really go to the figures documentation because for the most part, whenever I'm looking for how to plot like a time series or how to plot a bar plot, someone else has already made one that looks nice. So I can just take their code and put my data into it. So basically what these cell blocks are going to be is useful things that you can revisit when you're doing your assignments to just come take this code and plug in what you need. For the most part, this stuff does read kind of like plain text. It's not the most difficult thing to understand how to implement. But again, if you see the kind of fine tuning people can do within plotting, it's almost useful to just take people's templates and plug your stuff into it. So what I'm going to do first is I'm going to do a bar plot that segregates my data into different proportions. So what I'm going to do is I'm going to take the data I have on the cases and I'm going to split it into total recovered versus active cases versus total deaths, which should encompass everyone. Everyone's in one of those three categories. And yeah, and all the data that's being reported on this website is specifically, they have to have at least contracted COVID. It's not just the population. So everyone should fall into one of these three categories. And so what I'm doing is I'm just doing some reformatting here, where basically the certain values that I have, I'm converting from totals into, or proportions into percentages. And I'm labeling everything as the virus that I'm looking at, which is COVID-19. This is purely for aesthetic purposes, since the data I'm looking at is entirely COVID-19. If I had other viruses, I could segregate this out further, but this is just a formatting thing. And then I'm just making a bar plot of my data. Again, I'm just restricting to these three columns that I was interested in. And I'm looking at the first row. So if you remember, the first row is just the data for the whole world, not a country. So I'm looking at this whole data set. I'm making a figure, doing some centering, setting the sizes of the fonts, just fine tuning further. And importantly, I'm making sure that the renderer is Colab. So again, this goes back to an earlier point that when you render images on the cloud, sometimes it'll just display it on your web browser. Sometimes it'll try and save it locally. If you set the renderer to Colab, it'll just render it within the notebook, which is useful if you just want to visualize it. And what you'll see here, so this is outdated. Did I run this on? Yeah. Okay, yeah, so this is now formatted, the total number of cases, recoveries, and deaths for October 19th. It's sorted by color, and you'll see that it's presented as a percentage from 0 to 100. You'll see that the major block of people are in the recovered section, which is good. The second most is the active cases, and then the total deaths is the small fraction at the top. But you'll see that when I labeled everything as belonging to COVID-19, that gave me my x-axis label. If I had data for, say, the 2023 seasonal flu, I could present that data next to it with a similar tag. But the beauty of using these plotting environments is specifically the one that I loaded in here is nice because it's dynamic, and that when you scroll over different aspects of the data, it's going to give me further information. So for this bar plot specifically, if I hover over any color, It's going to tell me what the data is that I'm looking at. It's going to tell me what virus, which again, we're only looking at one virus. It's going to tell me the exact percentage instead of trying to ballpark it looking at the figure. And it's going to give me the total value. And that happens for each individual little subplot here. But yeah, this is a very basic bar plot. And then I believe I did another instance here just with different variables. So I also plotted the number of new cases, newly recovered, and new deaths for today. So if I run this, so this is the data for today. So you see the number of new cases is about 14% of the newly reported things today. Number of newly recovered people is about 86%, so 20,000. And it looks like there were 0 deaths today, which is nice. Yeah, that's basically all I have for bar plots. There are a lot of good examples for time series plots. I think that comes up in the homework, so I didn't want to specifically do that here. But again, it should be pretty straightforward to plot things in a time series. Yeah, I also did some grouping here just by continent, just because I want to look at the data in a different way and to demonstrate kind of further the power of using data frames versus just putting everything into a plain array. So this is just a more concrete example of a lot of the methods. So I didn't know there was a group by method for data frames. It's pretty useful if you have good labels. So specifically, if I want to group all my data by continent, then I can just sum up everything within this group, and then I can drop everything else. So I'm ignoring the everyone group. I'm just looking at continents, and then I'm printing the data in this format too. So I can basically reformat the data based on the information I have to be, instead of at the country level, look at the continent level. And that's, again, just kind of the power of using data frames. They're very useful. They're pretty fast in implementation. And they're definitely the best way of representing things. And you kind of get the feel for using data frames by using them. You kind of just keep doing it. And again, when you interview for data science positions and roles, then they're going to want you to be aware of pandas and like be pretty quick on your feet with these things. A lot of the times, if you get like a coding interview or like a coding assessment, I forget which company it was, but last year I had to do one where they gave me 3 problems, and all of them were specifically manipulating data frames, doing basic data analytics on a data frame that's given. So these are like the staples of things you should know going into the job market. Okay. Any other questions before I go to model fitting?
Yeah. The grouping by continent, there was another column that had continent for each country.
Mm-hmm. Yeah, exactly. So that was a feature. I'm grouping it by a feature. Okay. So again, model fitting is pretty self-explanatory, as long as you know kind of the basic practice of creating a training set, creating a test set. Again, you should know, especially for interviews, you should know how certain models work. Like if you say, oh, I want to build a least squares regression for this data, a lot of the times your interviewer will follow up and say, okay, what exactly does that entail? What is a least squares regression? In practice, you don't really need to know what something is to implement it, but you should at least have some sort of vague awareness of it, especially for interviews. So what I'm going to do here is I'm going to use the newly recovered count for a given day as the prediction variable, or the independent variable. And then I'm going to try and predict the number of serious or critical care individuals. So I don't know if there is a relationship between those two values. We can kind of compute that here and see if we can build a good model to predict the number of serious or critically injured people on a day given this data. So yeah, what I'm doing in this cell block is I'm just building the most basic model. So using newly recovered as my input, I'm going to try and predict using a least squares regression. And what I'm doing here is I'm not splitting it into the training or test set. I'm just using all my data as training to build a model. And what this is going to do is this scikit package, or I guess we're in stats model, but this least squares regression, what it's going to do, when you run a least squares regression, you inherently compute correlation coefficients. So that's going to give me R-squared values. And so that's what I'm doing here. I'm just using this kind of model functionality with the stats model package from Python to compute the correlation between these two variables. And again, all these Python packages, people have worked incredibly hard to make these very easy to use and very helpful. So specifically, after I build a model, I can always run the .summary command, and it's just going to summarize exactly how well this model worked for me. So if I build a least squares regression using this predictor, I do a model summary, it's going to fully output everything that it did. So it says, I'm trying to predict the serious or critical count using a least squares regression. What time was this run? The number of observations I have. And specifically, it's going to give me the R squared value, which is kind of what I wanted. So it's telling me that the number of newly recovered people has a 0.8 about R squared value for prediction of the serious or critical amount, which is a pretty strong correlation. So maybe you want to use that in your feature set to predict in the long run, whatever your model may be. But yes, this gives me an R squared model. So it says, maybe there are other features that are more predictive, but I'm going to start trying to build models around this feature. So what I'm going to do now is I'm going to get into the actual kind of model fitting for the purpose of building a model that generalizes well outside of my data. So what I'm going to do is I'm going to mask out certain data. So I'm going to randomly select data to remove from my training set, and that'll be my test set. So I'm just dividing the data I have into training and test set, because you don't want to train on all your data, because then you're just going to give really good low error values because you've trained on all the data you have. And so obviously you can predict your data. So you need to segregate into training and test data to ensure that you can generalize. So what I've done here is I've just randomly selected a number of observations to remove. I think I just removed 10 of the 200 or so that I have. I'm going to divide that into my training data and my test data. And the variables that I'm going to use are newly recovered, serious, critical, and population. And so what I'm going to do is I'm going to build a model that uses the number of newly recovered people and the population to try and predict the serious or critical count. So we can do that split here. And what am I loading in here? So from scikit-learn, I'm loading in mean squared error, which is a very basic measure of error. There's a number of different ways to measure the error in your model. Mean squared error specifically is doing my predicted value minus the actual value, take the square root, or square that, take the sum of everyone, take the square root. So that's a mean squared error. And you can use a number of different error measures. But so now what I'm doing is I have my training data for my independent variables and my training data for my dependent variable. And that's what I'm going to build my model on. And then I'm going to apply it to my test data and get an error measure. So this is kind of the very basic pipeline for building a generalizable model. So same thing that I did before, I'm going to fit a least squares regression model using my training data. And then using that model, I'm going to try to predict my test data. And so now I have predictions for these variables y. I can compute the error between my predicted values and the actual values, and I can print out that error. And so when I print my root mean squared error, we see that my error is 150.328. Actually, if I rerun this, it'll be different. Okay, so it's like 20. So that's a low number, cool, but that doesn't really mean anything in a vacuum. Like 20 has no unit to me. I have nothing to compare it against. So yeah, in a vacuum, this number means nothing. So what you need to do is you need to try fitting other models using different variables and see what happens to the error. Does it go up? Does it go down? Obviously, you want to find your global or local minimum for this error. So we had 20 here, cool. In linear regression, I guess if it's 0, that should be a concern. Obviously, if your error comes back as 0, something's gone horribly wrong. There is a 0% chance you build a perfectly predictive model, I promise you. So if you get a 0 error, then you need to do something different. So least squares regression kind of worked. I can do the exact same code pretty much where I fit, all I have to do is load in a different model. So all I'm going to do is load in a logistic regression. I'm going to do the exact same procedure. And when I do that, it looks like my error goes down to 7.8. So again, now I have 2 data points to look at and the error has gone down. So I know at least to some degree, a logistic regression works better than a linear regression here. But again, we don't know if that's the best possible. So we can repeat this procedure. I think what I use here is a support vector machine. You see, we get ever so slight improvement. So you can kind of speculate that, okay, maybe this is the best I can do. And yeah, what you'll note here, especially if you're looking at the code, the process of fitting a model is very modular. You're literally just loading in models from a Python package and you're saying, okay, fit model and predict. For this is the least squares prediction. I fit a model and I predict. For logistic regression, I call fit and then I predict. For SVM, fit and predict. Like you can really do this with any model very easily. There are some parameters to be tuned for each type of model. So specifically for when you build like a multi-layer neural network, there's definitely a real art into how many nodes you want to have in each layer of your neural network, how strong are the connections initially. And yeah, there's no real way of knowing the best parameters to use in those big instances. And if you get really good at finding the right parameters and tuning very well, people will pay you 6 figures just to tune models for these neural networks. Like it's a very non-trivial thing that's incredibly useful if you can do it well. So what I did here is I just built a very basic multi-layer perceptron regressor with 2 or 3 random initializations for these parameters that I just mentioned. I'm personally really bad at tuning these parameters, so no one's going to be paying me to do this. I always just start with like a very small alpha and then like 10 hidden layers. Sometimes that works, sometimes it doesn't. It looks like my error went down, so I guess that works. But again, it's the same thing. Even though I specified a few more hyperparameters here, you're still just doing fit and predict. It's the Python pipeline is very easy to use for data science. That's why everyone is very well versed in it. R is also very easy to use for those who use R. But for the most part, when you do like an interview, most people are going to be very familiar with Python, just because of all the packages that you can use in that. Yeah, and just one more thing, I built a gradient boosting regressor, but that's kind of the extent of this very brief overview of data analytics through Python. I'm going to leave the rest of this time to help you out with specific questions or answer any further questions on this stuff. I know that some people have been intimidated by the first Python assignment. I assure you it's not that bad. It's just a matter of getting used to which functions to call when and how to actually manipulate your data. So I hope that this notebook will be a useful resource in that. But yeah, any questions on this? Cool. Okay. So I will stop the recording.